Hello again everybody and welcome back. This is the fourth video in the OpenCV 2.4.11 installation guide, and in this part we're going to cover, this is actually broken into four separate parts. We're going to cover OpenCV compilation from source, and then once we've done that compilation from source we'll cover configuration with Visual Studio 2013, and then we'll cover configuration with Qt for a non-GUI program, and then configuration with Qt for a GUI program. So let's dive right into it. Part 1, OpenCV compile from source. So at this point you should download and install Visual Studio 2013 Community Edition if you have not already, and if you're unclear on this step, please refer to the first video. Continuing on here, step 2a, download the latest 32-bit version of Qt, for example, the following executable here. So let's take a quick look at that. And if we go to Qt and here, and it should pop right up. Yep, there we go, download now. And you can get the pay versions if you're going to be a professional developer in Qt, but for now we'll just go with the Community Edition. And then download now this is actually the link you do not want to choose, because what this will do is it will download an installer onto your computer, and then it will check if your computer is 32 or 64-bit. And probably everybody watching this video has a 64-bit computer, at which point the installer will download and install the 64-bit version of Qt, which we don't want to do that. So go down to this point here and then choose View All Downloads, and again skip by this. That's the online installer that's going to auto detect 64-bit on your computer, and instead go down to here and look for Windows 32-bit Visual Studio 2013. So either of these. And the difference here is that I'd rather not get too sidetracked into a hardware discussion here, but the OpenGL version of course includes OpenGL as shown, and the non-OpenGL version includes Angle, which is a library actually written by Google, and it converts OpenGL function calls, or remaps them I should say, to DirectX. And the reason that Qt uses OpenGL is because it's written to be cross-platform. As you know, Qt programs can run on Android, Linux, Mac, etc. And of course DirectX is Microsoft's proprietary 3D function call software interface. So as a result, Qt of course is written to be in Microsoft operating system independent, so it's written making OpenGL function calls. So in other words, if you're going to eventually call either OpenGL or DirectX function calls from your program, or you're planning on doing that, if you want to make the DirectX calls, you would choose this one here that's not OpenGL. If you want to use the OpenGL calls, you would use this lower one. We're not going to get into that today. And even if you do plan on calling OpenGL function calls, any remotely recent installation of Windows 7 is going to have a pretty current version of OpenGL. I mean, unless you have a really old computer or a very obscure video card that doesn't have common support. So I would recommend downloading this version here. And once you've done that, you can go ahead and choose the default options. Those will work just fine for you. And then the next step is download OpenCV 2.4.11 and then make this folder OpenCV 2.4.11 and extract OpenCV 2.4.11 of there. That's the same as in the prior tutorials. Step 3C here, however, is new. Make a folder C OpenCV 2.4.11 my build. So let's go ahead and do that now. And that's where we're going to put our compilation. So OpenCV 2.4.11. So OpenCV. So this is the extraction. So we won't touch that, and instead anything that we're going to do, we're going to put here in my build. So in other words, this is theirs and this is ours. So continuing on here, download the latest version of CMake. This is the standard tool, and you want to get the Windows 32-bit installer. This is the standard software tool used for compiling OpenCV. So CMake, and of course it's completely free. So we go here, and then we scroll down, and then it's on the lower right here, download CMake version 3.2.2. And then it's definitely going to be easiest for you if you get the Windows 32 installer. So this right here is what you want to download and install. And you can choose the default options with one exception. When you get to the step where it asks you about path, you want to choose Add CMake to the system path for all users, and then go ahead and reboot. And next, in Windows Explorer, let's navigate to this directory here. I didn't mean to grab that quote. just paste that in a notepad for a second and take the quote out. Okay, we're going to go to that directory there. No, we don't want to save. And if we paste that in here, and what we'll find in this directory are a number of Qt DLLs, and these will need to be seen at two different times. These will need to be seen by CMake when we are compiling OpenCV, and then also when you're running an OpenCV program later on if you've included Qt in the compile. So at this time what we want to do is we want to grab our path here, or we want to grab this directory rather, and then we want to add that to our path. So let's go ahead and do that now. So start, control panel, let's see, where's system? There we go. Advanced system settings, environment variables, and scroll down to path in this bottom window here, and then edit. And then we'll press N to take us to the very right side, and then add one semicolon, and then go ahead and paste in that Qt path that we just highlighted a second ago in the cheat sheet, and then OK, and then OK, and then OK. And of course, please bear in mind if you're using a slightly newer version of Qt, this here will be slightly different. Please make the changes as applicable. And then at this point, I should have put to reboot here. Sorry, I didn't do that. I'm going to add a 5C reboot to the cheat sheet at this point as soon as I'm done recording this video. And so at this point, I'll pause the video and reboot. Okay, so reboot's complete, and also added a step 5C here, reboot, to the cheat sheet. So continuing on. Now we're going to start CMake, and I'll move the cheat sheet over to the other screen here. And we can copy and paste. I'm just going to copy and show you here what I'm doing. We're going to copy and paste these right out of the cheat sheet into CMake. So where is the source code? It's right there. And where to build the binaries is going to be right there. And then we're going to press configure, and here we're going to choose Visual Studio 12 2013. Note, please don't choose Visual Studio 12 2013 Win64. I really recommend sticking to the 32-bit compile. Your chance of running into concerns later on, especially if you integrate with any other software, are much reduced if you stick to the 32-bit version. So we're going to go Visual Studio 12 2013, and then use default native compilers, and then finish. And it's generating. We just have to give it a moment here. When it's done generating, what we're going to see is a whole bunch of red lines here, and what that effectively means is CMake is proposing to us. They're saying, this is what we found and what we think we should do. Do you agree? And what we're going to do is we're going to make one change to that. We're going to check the with Qt option to include Qt in our compile, and that'll be towards the bottom. Probably be done in just another second. Okay, progress bar is almost done here. It gets faster towards the end, and there we go. So all these options are fine except for this one down here with Qt, and then we want to check that, and then we want to press configure again. And now everything that was up here before in red will be white, and there'll be some additional red lines, these here for the Qt libraries. So in other words, now CMake rather is asking us, we think these are the right Qt libraries, are they? They are. So now we're going to press configure again, and then we should have all white. And this will just take a second. And there we go. So now we should have white top to bottom, and sure enough we do. So now we're going to choose generate, and while CMake is doing that, we'll navigate to C, OpenCV 2411. And remember, we just made my build recently. It was totally empty, and now all this was just made by CMake. And if we scroll down, what we're going to find is OpenCV.sln, and we're on step 7a at this point if you're following along in the cheat sheet. We're right here. And OpenCV SLN is a regular Visual Studio 2013 solution file. So if we double click that, Visual Studio will open up for us. And OpenCV, of course, is a huge program, so it's going to open, and then it's going to parse some files down here at the bottom. Yeah, there we are, initializing projects, and then it's going to parse files. So I'm going to pause the video. This takes a good 3-4 minutes. Okay, so now parsing files is done at the bottom here, and it says ready. So next thing is make sure that this is set to debug, and then Win32, and then go to build and build solution. And of course, again, OpenCV is a huge program, so this is going to take a minute, so I'm going to stop recording again for a moment. Okay, so our compile just finished, and here we have, as you can see, a number of warnings. And let's check for any errors. Okay, we have one error here: cannot open file python 27_d.lib. As long as that's the only error that you get, then we're all set, so we can save and then close out of Visual Studio. And then continuing along with the cheat sheet here, we're on step 8. Here we need to update our path variable. So just in case you're interested, we can look at the OpenCV 2411 mybuild bin debug directory. And of course this is where our compiled DLLs are, in particular here OpenCV calb3d.dll, and where some others, contrib, core, and so on all the way down. So those are the DLLs produced by the compilation process, so that was successful. So let's go ahead and update the path variable. So something to keep in mind is that if you followed the first tutorial, which you probably did, then the pre-compiled binary location will be in your path variable. So if we go path, and there it is, OpenCV 2411 OpenCV build x86 vc12 bin, and we know that's the pre-compiled one, of course, because it has OpenCV 2411 and then OpenCV, whereas the one we just did will be 2411 and then my build. So we need to get that one out of there, and then we need to add this one. So I'm going to Control C that, and then go to Control Panel, and where's System, there we go, and then Advanced System Settings, Environment Variables, scroll down to Path, Edit, and then I think it was the second one back if I recall, OpenGL, that's the Qt one, and there we go. OpenCV 2411 OpenCV, that's the precompiled binary one we have to take out. And a few deletes there, and a few more. And now we have 2 semicolons, so we deleted that completely, and then we'll Control V paste in the OpenCV 2411 my build bin and debug, and then choose OK, OK, and OK. And then we can go ahead and let's dump it to the command prompt here, verify that, path, and there we go. See, OpenCV 2411 my build bin and debug, so we're all set. So I'm going to stop recording here and reboot, and then it'll be on to part 2. Okay, so now continuing on to part 2, configuration with Visual Studio 2013. So we're going to go ahead and fire up Visual Studio. And let's see, we don't need that to be that big, and we close out of that, and we can close out of that. And this is going to be very similar to the first tutorial. In fact, almost identical, just we're going to use a few different paths per our recent compile from source. And of course we have to decide which of the programs on my GitHub page we're going to do. So let's see, let's go ahead and we'll just use this first one, cannystill.cpp. Anything will work as far as a proof of concept. And now continuing on with the cheat sheet, so File, New, Project, and we're going to do, let's see here, Visual C++, Windows 32 console application, and I'm just copying and pasting out of the cheat sheet here, so let's call it cannystill2, and we're going to browse to C++, Visual Studio 2013 Prog, C++, or wherever your preferred directory may be. So Win32 console application, name it, choose location, uncheck those, and next, and uncheck those, and then empty, check empty project, choose console application, and choose finish. And then we're going to right click here and do add new item, make sure it's on C++ file, and we'll name it the same name as the project.cpp. That's all set. That's good. Okay, and then we're going to copy and paste in this example here from my microcontrollers and more GitHub page. And of course we're going to get a whole bunch of red underlines because we have not told Visual Studio yet where OpenCV is. So following along in the cheat sheet, just forgot a step here, we got to get that image again. So if we go to C, Visual Studio 2013 Progs, C++, and we'll just grab it out of cannystill1 and copy it into cannystill2. There we go. Now the image is in cannystill2 as well. And now we're ready to set our paths within Visual Studio. So if we go to Project, Properties, Configuration Properties, Visual C++ Directories, Include Directories, and the Include directory you'll note is the same as it was before. That's okay. So there we go. I'm just copying and pasting out a cheat sheet here. So copy that in there, leave all this the same. The library directory, of course, is different. And that's the one that we just built. So there we go, paste that in, OpenCV 2411, my build, lib, and debug, and just leave all that how it is, that's fine. And then go down to linker and then input. And I should mention that the directory here has changed from before, where all these library files are, and with the build from source there are separate debug and release directories. So you now no longer have the ones without the dot, without the D before the dot, and then the D before the dot, but we have these other ones here, so we'd have to copy the name of that, and so on all the way down, or you could just verify those are the same as in the cheat sheet here, which they should be, and then you can copy this in here. So up here, additional dependencies, and then edit, and then copy it all in, and then choose OK, and apply, and then OK. And let's see, I'm going to consult the cheat sheet here for just a second, make sure I didn't miss any steps. Okay, so then verify this is on debug in Windows 32, and if I didn't forget anything, run it, and it should run okay, and yep, good, there we go. So there we go, working CV program with an OpenCV compile from source. So that concludes part 2. So now we're on to part 3, configuration with Qt for a non-GUI program. So let's dive right into part 3 here, configuration with Qt for a non-GUI program. Step 1 here is just mentioning do part 1 if we haven't already, but we already did part 1, so continuing to 2a. So from my microcontrollers and more GitHub page, let's go ahead and take a look at that. There's 4 additional programs we're going to go through at this point. 3 of which have on here have Qt in the name, and those are CannyStill, Qt.cpp, Canny Webcam, Qt.cpp, and Redball Tracker, Qt.cpp. However, those are programs, those 3 use a Qt front end. We're going to save those for part 4 of this tutorial. We're going to start with CannyStill.cpp, which does not use the Qt front end, and this is the same as the first program in the first tutorial. So we're going to go to raw, and here's what we'll be copying and pasting out of. And so now we can go ahead and fire up Qt Creator. And I'm going to move the cheat sheet over here, but keep following it. So new project, and then we're going to choose non-Qt project, and then plain C++ project, and then on the introduction to project layout screen, I'm simply going to copy the name CannyStill1 out of the cheat sheet, and we're going to save that to CQTprogs, and it'll make a directory CannyStill1. And then on this screen, what we're going to do, we don't need separate debug and release builds, and then we're going to change the debug name to be as follows: CQTprogs CannyStill.1, the same name and directory you'll recall as in the previous screen. So what Qt will do now is it's going to put the Qt project files and the debug build in the same directory, which is preferable for a program this small. We don't really need a separate debug directory for the build. So we're going to choose next, and we don't need any version control. And then this is CannyStill.cpp from my microcontrollers and more GitHub page. We're just going to copy that code over this entirely. And you'll notice we get underlines here, similar to the red underlines in Visual Studio, because we did not yet tell Qt where the OpenCV install is. So that's where we'll go to CannyStill1.pro. And continuing with the cheat sheet here, as we get down here, these are the lines that we're going to copy and paste into our profile to let Qt Creator know where the OpenCV include and library directories are. So if we go ahead and do that, and then it's suggested to leave a blank line at the end of your profile. And then if I didn't forget anything, we should be able to go ahead and run it. And whoops, okay, I forgot to put the file in there, so the image file, that is to say. So if we go back here, and then that, by the way, that also proves out our error checking. So then we can go say picture as C and Visual Studio 2013, what, not Visual Studio, QTprogs, CannyStill1, and we'll save image to there. And then we can go ahead and run it again. And if I didn't forget anything else, hopefully, nope, good. Okay, so there we go. There's proof of concept, and we're done with the first part. So now we're going to continue on the cheat sheet here. We're going to get down to part 4, configuration with Qt for a GUI program. Okay, so continuing on with part 4 here, configuration with Qt for a GUI program. So we'll go ahead and fire up Qt Creator again, and then we're going to go to New Project, and then on the New Project screen we're going to choose Application and Qt Widgets Application, and then Choose. And on the Introduction and Project Location screen I'm going to copy and paste in CaniStill Qt1, and there we go, use as default. And then on this screen we will choose the same directory, we don't need a release build, and then we'll make the debug build the same directory, there we go, and next. And then for class name, I always like to choose FRM main for my form name. You can choose a different name if you like. And then base class, make sure that's QMain window and generate form is checked, and you'll notice Qt Creator has named these 3 for us. I recommend to leave those just how they are. And then project management, we don't need any project management, so we can choose finish now. And let's go ahead and copy in the lib and include path line into the profile as our first step. Again, simply continuing down the cheat sheet here. I'm on step, let's see, 8 if you're following along. So copy that in, and then we'll jump on to step 9 here in just a moment. There we go. Okay, so now on the left here, choose Forms and then FRM main user interface. And we don't really need, for this program, you can have this menu bar and toolbar at the top and bottom of the form if you like, but for this program we don't really need those, so we'll just go ahead and remove them, remove, and remove, and then remove. And then let's see, continuing on the cheat sheet here, step 10. So in the Object Inspector window towards the top right, once you're in the form editor, okay, we just removed the toolbar and such that we didn't need. So step 11, so now depending on which example we're doing, so let's do CaniStill Qt first. And by the way, this is not an actual C++ file here, CaniStill Qt.cpp. It's actually 3 files in one, so you can copy and paste everything you're going to need for this project out of it. And what's included is the entire profile, and then the .h file, and then also the .cpp file. And you're going to see the syntax highlighting is effective once you get down to the C++ code, but of course since we titled it CPP, GitHub doesn't know to syntax highlight the .profile. That's fine though. So once we go to raw, and then we're going to begin copying and pasting. So here's the names of the Qt widgets that we're going to add to our form. Button open file, label chosen file, and then in Qt you use just a plain old label. So label original and label Cani to show OpenCV images. So now we're ready to go ahead and place our widgets on our form. So there's a button, and then we need our 3 labels. So 1, 2, and 3, and then you can set the properties. You can follow along with how I'm setting them here, or set them a little differently if you prefer. So I like to resize these labels first here, and then choose each of the 3 labels, and then I always like this autofill background property, that way you can see where the labels are, and we don't need any text in that or that. And for the label and button at the top here, let's make the font something much bigger. So let's go with good old 12, make it nice and big. And then we're going to put the text in for our button here, so let's put that as open file. And then we can make this top label blank to start with. Whoops. Okay, I meant to delete the label text. There we go, and this should be open file. Okay, so next step here is to kind of more or less resize the widgets to an approximate size. Actually, let's set the frame property here. Frame shape box, that way we can see where they are a little bit better. And we should also name the widgets too, and then we're going to use the layout managers in just a moment to assist us in placing components. So let's see here, and again I'm copying and pasting the names for these just right out of here. So button open file, and there we go, paste that in, and then label chosen file, So that'll be this one up here, and then label original will be the label on the left for the image, of course, and then label canny will be the label on the right. Okay, so continuing on down the cheat sheet. So at this point, we're going to kind of continue with the cheat sheet and then also copying and pasting from the example code simultaneously. So continuing on down now, canny still pro qt.pro, so we already did that. And actually, let's jump back to the form, and then we're going to do the event for the button next. So if we click on the button, make sure we have it named correctly, button open file, and then we right click on the button and choose go to slot, and then double click on clicked, or you can single click and choose OK, and then that's going to start to write the button open file click event for you. And as you can see from our code down here, if we jump down to form main.cpp, we have a constructor, a destructor, the button open file click event, which we just had the Qt creator environment do the header for us, and then the only other function is mat to Qt image that converts from an OpenCV mat to a Q image so that we can display our image on a Q label. But this is not an event in the sense that the button click is, so we can copy and paste in this entire function when we get to it. So we're essentially done creating the form now, except for the layout managers. So I'll go ahead and show you how to use those. For those not familiar with Qt layout managers, these are very friendly and easy to use. So these, the button and the label at the top, we simply highlight both, and then we choose layout horizontally, and then we can go ahead and resize that. Now you'll notice it didn't know to auto size the button to a certain size. So if we click on the layout manager, and then we come over here and choose layout stretch, we would like the button to be as small as possible and the label to be as large as possible. So we're going to make this 0, 1. There we go. Now the button is auto sized down, and the label is going to take up the rest of the size for us. Then if we choose both of the labels we're going to show the image on, and then we choose layout horizontally, and then let's go ahead and resize that. And so that'll 50-50 split the two images. That's perfect. So now if we click anywhere outside of any of the widgets on just an open space on the form, and then we choose layout in a grid, that's going to put all that in a grid, and you'll notice it auto sizes as we would prefer, so that's good. The only additional thing is we would like the top row to be proportionally much smaller. So if we click on this here central widget, and then you can tell this is a grid because of this icon here. So then if you go down here to, let's see, we'd like to do row stretch, that would be, and we would like the top row to be as small as possible and the bottom row to be as big as possible. So 0, 1, there we go. And if we go ahead and start our program now, we should find that the labels with the images, or where the images will be, correctly auto size with the form, and sure enough they do. And it's a regular Windows form, of course. We can drag it around, resize it, etc. So we're all done with the front end now, and now it's just a matter of doing the code. So let's jump into, and we already did canny still qt1.pro. That's just copying and pasting in those. So now we'll do the rest of frm-main.h. So again, if you're following along in the example code here, we already did canny still qt pro. That's one of the 3 files we're going to be copying and pasting. So now we'll do form main.h. So basically I'm just going to shoot down here and copy and paste in everything that isn't already there. So if not defined, that's okay. QMain window, we need our 3 usual includes, of course. And then I'll copy and paste in the comment line. Why not? Makes it a little bit neater. And then Q object, that part there is fine. Just going to respace this a tiny little bit. Looks a little bit neater to my eye that way. You can respace things if you prefer, or as you prefer. And let's see, so this is our main form constructor and destructor. We don't need to change those at all. And private slot, Qt Creator wrote this for us when we chose that click event for the button. So the only place we have to add additional code here is in private. And we have some member variables and a function prototype to add. Whoops, okay, I didn't really copy that ideally. There we go. Let's try that. Oops, okay, did not mean to grab that main UI. Sometimes when you do this copying and pasting, the spacing gets a little odd, but that's okay. We can just respace it. So these, you'll recognize these images from the previous program. It's just the same four images: matte, original, grayscale, blurred, and canny. This was already there for us. This is a pointer to all the widgets on the form in code that you use, so you definitely don't want to alter this in any way. And then this is the prototype for our function matte to QImage. So now we're ready to jump into form main.cpp. And so I'll show you on the example code. I'm just continuing on down here to form main.cpp. This is the last of the three programs we're going to copy and paste out of, or last of the three files within this project, I should say. So include, those are okay at the top, and then we're going to put in QFile dialog and Qt core as well. And then we have our constructor and our destructor. We don't need to change the constructor at all, just neaten up the spacing here a little bit, make it slightly more readable. There we go. And same for the destructor. Okay, grab the comment line. And now we're on to button open file clicked. Header's already done for us by Qt Creator. So all we have to do is paste in the body. And let's grab the comment line as well. There we go. And finally, we're going to copy and paste in matte to QImage at the very bottom. And that's it. We'll just quickly go over the code here. Again, this is going to look very similar to the previous programs. This here is opening a QFile dialog so that we can get the file name graphically, very friendly to the user. If the user didn't choose a file, for example, if they chose cancel, then we would show on the label file not chosen and then return from the function. Supposing that a valid file, a file at all was chosen, we're going to check for if it was opened successfully next. But supposing a file was chosen, we're going to attempt to read an image out of that into matte original. And if for some reason that did not work, then we'll print a message to that effect on the label and then return from the function. So at this point we have a valid image. So we're going to set the labels text property to the file name so the user knows which file we opened. And then we're going to, and this is going to look very similar to the previous programs at this point, we're going to convert color, then Gaussian blur, then get canny edges, and then these two calls here are calls to matte to QImage, which is this function down here that converts from the OpenCV matte type to the QImage type. So for both the original image and the canny image, we're going to convert from a matte to a QImage. And then we simply, on the label original and label canny, we're going to go ahead and show those images with these two lines here. And that's pretty much it. So I'll go ahead and start it, and hopefully if I didn't forget anything, there we go. And we can choose open file. And of course we didn't have to save the image to this particular directory because we can choose it from anywhere we like. And there we go. So we're all set with that. And that was successful. So let's see where we are. We can go ahead and close out of that. And now we're going to jump effectively back up to the top of part 4 again, and then we're going to do the two remaining programs on my microcontrollers and more page, which are going to be canny webcam qt and then redballtracker.qt. So continuing on, we'll go through part 4 again. For let's do canny webcam qt.cpp next, and then we'll go to raw. And I don't think it's necessary to explain the steps through quite so much for these last two here. So we'll go ahead and fire up Qt Creator and new project and application, QWidgets application, and we'll call this canny webcam qt. Again, I'm going to be copying and pasting right out of the example code. So canny webcam.qt, can't have a space in there, and we'll use that as our default project location. And then next, and details, release, and paste over that. So let's see, debug, same name, release is unchecked, that's good. And then we're going to call this frm main. And QMain window, that's checked, don't change those. Choose next, we don't need any project management. And let's see, so first thing, let's go to cannywebcamqt.pro, copy in our include path and lib lines. And now let's go ahead and do the user interface. So we're going to only need to add two labels to the form for this project. Let's get rid of all these here. Remove, remove, and remove. And then we're going to add our two labels here. So there's one, there's two. Go ahead and resize those. Again, we're going to use the layout manager in a second, so this doesn't have to be perfect. Just get them more or less close, and then we're going to reset a few properties. So we don't need any text on there. Don't need any text on there. Choose both labels. And autofill background, yes. Frame shape is box. And we'll go ahead and make the form a little bit smaller, and then I'll copy and paste the names right out of the example code. So the left one will be label original, and there we go, and then the right one will be label canny. So there we go, and then we'll highlight both of these, and then we will choose layout horizontally, and then restretch that more or less to the size of the form. Click on an empty area of the form here, and then go to layout in a grid. So let's go ahead and fire up our program here just to test that the form's working okay for us. And it seems to be, and yep, labels are resizing nicely, so that's all set. So now we can go back to code. So we're already done with Canny Webcam Qt .pro. So now we're going to go to form main.h and simply copying and pasting here, continuing on with the example code. So we're going to copy and paste in our three usual libraries there. And then let's see, QObject, so namespace is okay, and then form main, QObject's okay. And then public, we have our constructor and destructor, that's just fine. So the only additional things we need to add are here in private. And we're going to add the following. There we go, that pasted in a little bit better that time. So we have here the video capture object, and then the same four images, and then a timer that'll be used to, I'll cover that a little bit more in the form main.cpp when we copy and paste it in there, but that essentially is what we'll use to cycle showing the webcam frames. And then this mat to QImage function, same as in the last program. And then for error handling, we have this exit program function. So let's get into form main.cpp. And again, I'm just shooting down the example code here, copying and pasting as I go. So let's see, includes are good, and then we do need to add two more though, QCore and QMessageBox. And then let's add the comment line for the constructor and neaten that up just a touch. It seems more readable to me if it's all in one line. You know, you could keep it on multiple lines if you prefer. And we are going to add something significant to the constructor in just a moment. The destructor we will not need to change. Okay, let's get that up there. So for the constructor, here's where we're going to set up the connection to the webcam. So just a second here while I copy and paste this in. Okay, there we go. Definitely don't change the UI setup this line. So we're going to call cap webcam.open and then 0. So that's going to go to the default webcam. And then if webcam cap webcam is opened as false, so if we weren't able to successfully open it, then we'll show that information via a message box, and then we're going to call the exit program function that again we're going to copy and paste in a moment, and then we're going to return. Supposing that we were successfully able to connect to the webcam, we're going to instantiate that QTimer that we declared in form main.h, and then this line here, signal slot, connects the timer to this function process frame and update GUI, which again we're going to copy in down here in a moment, and then QTimer start, and then 20 is the number of milliseconds. So in other words, we're going to cycle the timer. In other words, we're going to call a process frame and update GUI, or we're going to attempt to do so every 20 milliseconds. Now that would be 50 times per second. Of course, it's not going to be possible to capture a webcam frame and do all the OpenCV processing 50 times a second. So what Qt will do then is it will call process frame and update GUI as many times as it can, while still allowing a very small sliver of time to handle events such as moving the form, resizing the form, etc. So the program still responds to user interaction. So now we can move on down past destructor. We don't need to change that. So we can copy and paste in all of exit program. That's just fine. So this is simply two lines. We're going to call this potentially, depending on when the program should crash due to the webcam not being connected or a disconnection during operation, we could end up calling it from the constructor here if we can't get a webcam connection to begin with, or also we're going to call it There it is being called once. And we also potentially could call it from process frame and update GUI, as you'll see in a second, if the webcam is disconnected once the stream has started. So when we get into exit program, we don't know if the timer has been started yet or not. So we have this conditional here: if the timer is active, then stop it. Of course, if it's not, then there's no need to. And then we'll call queueApplication.quit, and this will exit the program. And when we call exit program, it's also a good idea to be on the safe side and put a return statement after the call to exit program. That way, execution of the program will not continue after where exit program is called either. So now we can call, let's see, or paste in rather, process frame and update GUI. And this is going to look pretty similar to the mgu functions, actually kind of the same logic. We're going to call capWebcam.read to read in an image from the webcam. This is passed by reference and gives us, I should clarify that, this function call here will update mat original passed by reference, and read will also return a Boolean value, frame read successfully. So in this next if statement, we're going to check, and if the frame was not read successfully or mat original is empty for any reason, then we show a message box to that effect, and then we call our exit program function up here, and then we return. Supposing that we got the frame acceptably, just enter down a few lines here, then this is going to look very similar to all the other programs, of course. Convert color from color to grayscale, and then Gaussian blur, then get the candy edge image. Then just the same as in the last program, we're going to call mat to queue image to convert from a OpenCV mat type to a queue image type, and then we're going to show those two queue images on our labels. And the only thing remaining now is to paste in mat to queue image. And if I didn't forget anything, fingers crossed here, let's fire it up. It looks like I forgot to copy and paste in the function prototype based on this first error here. Process frame and update GUI is not a member of form main, so I must have forgotten to copy in the function prototype for process frame and update GUI. If we go up to the .h file, let's see, yes, this line here, public slot process frame and update GUI, is probably going to be missing from the .h file. Sure enough, it is, and it goes, let's see, right after queueObject, but before the constructors, so right there. And let's go ahead and run it again. And there we go. What a difference one line makes. And as we can see, our program works, and feel free to experiment with the properties if you'd like to get these to resize. Qt does offer facilities for that, but I'll leave that for you to do at your option. Okay, so now we're all ready to close out a Qt, and we can go on to our final program of this tutorial and the final program of this 4-part tutorial. Red ball tracker qt.cpp and raw, and let's go ahead and fire up Qt again, and then project, and let's see, application, QWidgets application, choose, and we'll call it red ball tracker Qt, uses the default project location, next, and details, uncheck release, make this name the same as the previous screen. Okay, that's good. And we'll make this frm main and qmain window and checked. Leave those how they are. That's good. We don't need any project management. So let's go ahead and do the .profile first. So this is just a straight copy and paste out of the example code for include path and libs. And now let's go ahead and do our form. So this will be pretty similar to the previous program, only we're going to have 4 widgets instead of 2. So we're going to have a label. Let's see here, first let's remove these unnecessary components here. So menu bar, remove, main toolbar, remove, and status bar, remove. And let's see, then we're going to have a label, and again I'm just starting here and working my way down. So we're going to have a label original, and then a label processed, and then we're going to have a button, and then for the .NET text box equivalent, what we're going to use here, we're going to find it's best, works best if we use a Q plain text edit. And again, you don't have to get these resizings too precise, just get them at least close, because we're going to use the layout managers later to auto size everything for us. So we can go ahead and expand these a ways, and then expand this quite a bit, and we can take the text out of here and the text out of there, and we're going to make the text on this button here, let's make the font a little bit bigger, nice and big. Let's go with 12, And then for our Q plain text edit, we'd like to choose, let's say 10, and then a fixed width font. Good old Courier New should always work for us for that. Let's see, where's Courier New? There we go. And well, let's go 11, a little bit bigger. And then we're going to make our button text say pause. And then I'm going to add a space, then type pause. And then another space. That way when the button is made a little bit bigger to fit the word resume, it won't have to change size. And just sort of approximately place the components here. And let's go ahead and name them all before we go any further. So I'm just going to copy and paste the names out of the example code. So this will be label original up here, and then label processed, and then button pause or resume. Whoops, grabbed a space there when I was copying. Take care not to grab any leading or trailing spaces when you're copying. And then text XY radius. And if we jump down here, we'll see that I believe the only event, if I recall, is the button event. So we're going to need to have Qt Creator start the button pause or resume event for us, but that's the only one that we need the environment to start. Okay, just double checking on that. So make sure we've named the button, and then right click on it and go to slot and then clicked, and there's the beginning of our function. So we can go back to the editor now. And let's choose the two labels, and it's a good idea to give it a frame. So box, yeah, that'll work. Okay. Then if we choose both the labels and then layout horizontally, and then we're going to choose the button and the Q plain text edit at the bottom, and then layout horizontally, and just kind of approximately size everything. Then click on an open area on the form to make sure you have the form selected. Then choose layout in a grid. And that's okay, we can handle that resizing here. So choose this up here, central widget, and then the grid. You know it's the grid, I should say, because of the grid icon. And then go down here, and let's see, we would like to make the top row take up as much space as possible. So we're going to go to layout row stretch and make this 1, 0. And there we go, that's good. So let's fire it up and just do a quick test on our form, make sure it resizes how we like, and that's pretty good. Alternatively, we could have done a ratio there. For example, if we wanted the two labels to take up 4/5 of the area, we could have made this 4, 1, and now the Q plain text edit will resize also with the form. As you can see, that works out pretty well. Yeah, I kind of like that. Let's leave it like that. And so now we're ready to copy and paste in the rest of our code. So if we go back to edit, we already did the .profile, so we can move on to frm-main.h. So shooting down in the example code here, so these if define and define are okay, include, just leave that how it is, and then copy in our usual 3 libraries. And then when we get down into FRM main Q object, we're going to go just past that, and we're going to include the function prototype for process frame and update GUI. That's the one I forgot in the last program and got all those errors from. We can leave the form constructor and destructor the same, and Qt Creator wrote this for us when we chose the button click event. So then we're going to go down to the private area, and we're going to copy in all the remaining code from the example. And this is going to look pretty similar to the red ball tracker from the other 3 videos. We have the webcam object, and then original and processed image. We have the Q timer one, the same as in the previous program in this series. And then our mat to Q image function, and then the exit program function. So we're ready to move on to form main.cpp. And let's see, the includes at the top are good, but we have to add Q core and Q message box. And then we have our constructor, which we are going to add significant code to. So let's just respace this a little bit here. And then just after UI set up this, we're going to copy everything else that goes in this function, which is going to be that. And again, the spacing sometimes doesn't quite work out when you're copying and pasting in, but we can fix that easily. these three statements as well. And I'm not going to go over this code, it's the same as in the last program. And let's see, the destructor, we can leave it just how it is. Go ahead and copy in the comment line though. And I just accidentally pressed Control B when I meant to press Control V. Of course we got errors because we're not anywhere near a completed build here yet. Now process frame and update GUI we can copy in, and we'll copy that in just in front of button pause or resume underscore clicked. So we can drop that right in there. And maybe we'll go over that. Well, let's go over it now. So this code here to get the image and check that, or to get the additional frame from the webcam and then check that we got it, is the same as the previous program. And then this is going to look pretty much the same as the red ball tracker from the previous part 1, 2, and 3 of this tutorial. We're going to blur the image, then in range to filter on color, then Gaussian blur again. Then we're going to perform a closing operation, that is a dilate and then an erode. And then we're going to declare our vector of circles, that's of type vec3f, and then hue circles we're going to call to fill that, that's passed by reference of course. Then this for loop here essentially is for each circle. We're going to update this text xy radius widget with the xy location and radius of the circle, and then we have the two functions here to draw the small green dot in the center of the circle and then the red circle around the detected ball. Then we call mat to queue image to convert our original and process mats to queue images, and then we show those on our labels. So at this point we can move on down to, well, we can copy in mat to queue image next. And then we can copy in on button pause or resume underscore clicked. And of course we already have the header there, so we're just going to grab the body of the function. And whoops, I did not mean to fold that code. There we go. And let's go ahead and grab the comment line for that as well. And hopefully I didn't forget any lines here this time. We can go ahead and run it. And based on the error here, it looks like I forgot to copy in the exit program function, so let's see where that should have gone. Let's see, there we go. It should have gone right after the destructor, so let's copy that in, and I bet that will resolve that. And there we go, respace it, and let's run it again. And there we go. And we'll also take a moment to prove out our error checking in just a moment, but let's go ahead and run the program just to make sure everything works as anticipated. And there we go, it's tracking the red ball. Okay, so we'll check the pause function. So pause, there we go. I'm still moving the ball, but as you can see, it's successfully paused. Now I'm moving it again. There we go. Pause, moving it again. And then I'll unplug my webcam so we can verify the error checking. We should get a nice message box showing the program's going to end. Yep, there we go. And exit the program, but it does not hang on us. And then if we start the program without the webcam connected, and there we go, webcam not read successfully, exiting program, and again it does not hang, so we're all set there. So that concludes the fourth part of this four-part series on installing OpenCV 2.4.11 and some example programs for OpenCV 2.4.11 on Windows 7. And just as a final tip, especially pertaining to Qt, when I was prepping for these videos, I tried them on 3 different Windows 7 computers, 2 of which I formatted the hard drive and reinstalled the operating system to make sure I was testing on a fresh Windows install for these. And in the case of Qt, I got some very obscure errors, and that's why I put in this part at the end here. If you get some errors that really don't make logical sense, in particular, I would get errors. I knew for a fact that I had the profile configured correctly with the include path and libs lines, but Qt would still give me errors saying that it couldn't find these libraries. And I found that if I went to build and then clean all, and then I would go to build, and then I'll just go ahead and do it, build and then clean all, and then build and then run qmake, and then came back down here and reran it, that fixed some very obscure errors. So that's just a quick Qt tip to keep in mind for you if you're experiencing some concerns with Qt. So that concludes this video series, and I'm not sure when I'm next going to be able to record more OpenCV videos. Hopefully pretty soon. Of course, it's all work schedule dependent, but you know, as soon as I can get to it, I'll see everybody in the next one.